This is question 3 of the Calculus 2 project. This problem has to do with Newton's law of cooling. The problem goes that you're cooking an apple pie for Thanksgiving. You spent all day making it, and now it's time to bake it. You bake the pie at 350 degrees Fahrenheit for 20 minutes. When you take the pie out, it has a temperature of 300 degrees Fahrenheit. You set the pie down to rest in a room with an ambient temperature of 70 degrees Fahrenheit. After letting the pie rest for 1 hour, it has a temperature of 180 degrees Fahrenheit. You cannot eat the pie until it cools down to a temperature of 100 degrees Fahrenheit. Use Newton's law of cooling to determine how long it'll take until you can start eating the pie. Okay, and here is how you solve the problem. You'll use Newton's law of cooling formula, which is this. Big T represents the temperature in Fahrenheit, and little t represents the time. K is a constant, T, or big T, is the temperature, and 70 represents the ambient temperature of the room. We are given the information that T of 0, or the time when you first take the pie out of the oven, the pie is 300 degrees Fahrenheit. Then after 1 hour of resting, the pie is now 180 degrees Fahrenheit. We'll be using this information to solve the problem. So the first step we must do is separate the variables, putting big T on one side and then little t on the other with k. After that, we will integrate both sides with respect to their t's. When we integrate this side, we'll get natural log of big T minus 70 equals kt plus c1. We undo the natural log by raising everything to the e, which makes this side big T minus 70 equals e kt plus c1. Now we bring the 70 over to the other side, and we bring out the c1. We make it e to the c1 times e to the kt. c2 equals e to the c1. These are different c's, so we have to make that known. Now the function equals t to the t, or just the function of t, equals 70 plus c2 e to the kt. Now that we have this equation, we must solve for c2 and k, because we do not know what those are yet. Up here, we're going to use the initial temperature of 300 and time equals 0 to solve for c2. So you plug in 300, and when you plug in 0, the e to the kt cancels out. So now you got 230 equals c2. Now you need to solve for k that you have c2. So you plug in the temperature after 1 hour, and this is where you get 180 equals 70 plus 230 e to the k. We go through the steps to solve that, and we get k equals natural log of 11 over 23. Now all we have to do is plug in c2 and k back into this formula, and we get our equation for the cooling of this pie, given in the room that is 70 degrees. Okay. So now that we have the formula, we have to find out how long it will take until the pie reaches a temperature of 100 degrees. So we plug in 100 into the temperature, we leave everything else the same, and we're solving for t. We go through the steps to solve for t, and we find that t is about 2.761 hours. We put that in a paragraph form explaining what that actually means. So based on the Newton's law of cooling, it'll take 2.761 hours for the pie to cool fully. And that 2.761 hours is from the time of taking the pie out of the oven. So if the pie has been resting for 1 hour already, you must wait another 1.761 hours. And that is how you solve the problem.